Can we get your attention? Can we have everyone's attention? We're going to go ahead and begin. So, much nicer day. In a few more minutes, probably really, really warm, and by noon, I think that it'll be. Well, yeah. Then we'll want to move back inside because it's too hot. So, all right. I'd like to, introduce someone that I know that you're going to really enjoy, and say a few words about just how I met him. And I think I may have mentioned it a bit before, but I think I'd like to go over it again. We had a conference here last year, and we had some of the finest research astrologers in the world here, including Tom Shanks and Michelle Gokalan and Robert Hand and Sweetbird Ertl, many, many other people. It was really quite special. And of course, we had John Townley. He's not here this year, but most years he has been here. He's an old friend of mine, and he said that he wanted to bring this person with him named Robert Schmidt. Fine. And did I have a place to put him? And they're going to have a wild tour across the country in a car to get here, and stopping to pick up Robert Schmidt, who lived in Cumberland, Maryland. And I didn't know him. And he arrived, and John introduced me, pointed him out, and I had to get John aside. John is very, I don't know how many of you know John, but John's very, I don't know, democratic, egalitarian, I don't know what the words are, but very open about anything. You could try anything. I mean, he's certainly tried anything, if anyone knows him. So I took him aside and I said, well, who is this Robert Schmidt? I mean, should I put him on the panel, or should he be just, does he want to speak? Does he want to be part of the speaking thing? I'd never heard of him. And John in his characteristic way just said, oh yeah, put him on the panel, right? This is what a great idea. Of course we want to put him on the panel because and see what happens. And, well, is he an astrologer? Oh, no, he's not really an astrologer. What is he? Well, he's a kind of a theoretical physicist, and he's done a lot of work in mathematics. Fine. So anyway, I think we had this huge panel. We were right out here in the same yard, and I think we had at least 3 or 4 tables crossing the whole back of the yard, just filled with panelists. We all, Mark Urban Lorraine and Doug Pierce, and it was an incredible array of people. Dr. Lee Lehman and all that kind of stuff. Sometimes I just call her Lee Lehman, but sometimes I call her Dr. Lee Lehman. But anyway, so we began to have a discussion, and we, I don't remember what the topics were. Maybe Bob does, but somewhere in the middle, I got in a dialogue with this Robert Schmidt character, and I'd never even spoken to him other than to say, hello, how are you? And then suddenly, here we were talking about this whole concept that he has of intensive magnitude, and I had something similar in my own life. And before I know it, we were having this intense conversation. Before I knew it, I was reciting poetry, all kinds of stuff like that. So I mean, it was very profound for me, and it was very profound for Robert. And afterwards, of course, we got together and had some other conversations. Now that there was a kindred spirit. There's some information that we both had tuned into, highly tuned into, that we both resonated to. There was a feedback cycle and happening. Definitely. That was going on. And to make a long story short, like I'm always doing, Robert came back up again to have some more discussion, and pretty soon he decided he wanted just to move he didn't care too much where he lived. He wanted to bring everything he owned up here and just sell in this area. He has a printing press, and he's published lots of mathematical books, and he does very fine printing work, special editions, small numbers of copies of, they do an excellent job on it. And so they brought the whole thing back up here, and pretty soon we were just kind of working together on a regular basis. And of course it's been a major asset to Matrix because it gives us a real research focus that we kind of need, especially when Doug Pierce left. We lost our statistician. He went back to school to learn more about artificial intelligence, which is good, but that's his main interest. And we were sorry to see him go, but Robert has kind of filled in some of those shoes, and we're working on many kinds of things. So I think he's one of the unique talents in the world of astrology today, even if he doesn't call himself exactly an astrologer, that's fine by me. Haven't even asked him lately, but I think that you'll enjoy hearing from him, and if you haven't had a chance to meet him personally, you really should take some time to. So I'll present him. Well, just somewhere pretty high.
Is that okay? Well, I want to acknowledge that introduction by Michael, and also just let everybody know that that was a very rare moment for me, too. When I first met Michael on that panel, it was something very unusual. And just for a minute, I'll say something about that, because when I was, before I had come up here, I had been doing some very sort of detailed, very intense thinking on some things that had to do with physics, unified field theory, all kinds of grand schemes like that. And and I had been using these images, just metaphors for myself, to sort of keep the mathematics from going astray. I had to have something concrete that I could look at and make sure that I wasn't just going off in some, sideways direction when I was trying to think about these things. And I had used 3 or 4 of these, and that sort of kept to keep me in check. And so what sort of stimulated this this meeting with Michael, and the thing that was so remarkable to me, is that when I started to introduce this concept of intensive magnitude, which I didn't intend to talk about at all when I got up here, and Michael picked up on it, and then very soon Michael was using these same images that I had been using to keep the mathematics in check, and he was giving them back to me. And even though they had come from a completely different background and a completely different orientation, and more psychological perhaps, if that's not an incorrect term. And so it was very remarkable to me to have the stuff coming back from somebody else in almost exactly the same metaphorical formulation, and so that was the basis of our meeting. And I mention that because to some extent everything that I'm talking about is related to those same issues, although it might be hard to build the bridges and make all the connections, and I won't try to do that entirely. I think what I'm going to try to do is say something about the broader significance of chaos theory and how that might have some bearing on the reintegration of science and astrology, not knowing much about astrology, but maybe having an attitude toward the world and the universe that might be considered astrological. And I'm not going to do a lot of technical, try not to do a lot of technical explanation of these chaos concepts, and I'm going to try to talk about some of the basic concepts that you've probably all heard about, and then try to maybe show how that if we follow them out and think about what they're really trying to say, they might point to a different sort of realm of things that could in fact be of importance to astrologers. And then I will leave the astrologers to do the rest of the work. So this is mainly an attempt to just sort of grope around with the concepts a little bit, get down to the level where we could see something and see the suggestiveness that these new concepts in chaos theory really have. And the one thing that's interesting is that you've all read about it, and it's a new development in physics, but the thing that's so interesting about it to me is that the people who are doing the work themselves are sort of caught up in it. It's almost as if it's not just a new theory, and it's not just a new way of using mathematics or a new approach. You find people who will be looking at computer screens as these strange attractors form, and they're just completely captivated by it. They're seeing something, and they're being drawn into it, but they're not entirely sure what it is. I mean, they have ways of formalizing it and ways of describing it, but there is just something that is almost hypnotic about it. And it's almost as if this is a new image of some kind, perhaps a pre-image, if I intend to return to that word often in this talk. And it's almost as if the there's a new vision that is that is in the making, but has not been completely formed yet. And similarly, the other side of this new development in physics came from a completely mathematical direction by a man named Mandelbrot, whom you've all heard of. The Mandelbrot set is named after him. And he began to do something a little bit different. He was interested in just geometry, the geometry of nature, and the way things, the shapes that things really had. And you are all familiar with, going back to the Greeks, the world is basically made up of circles and straight lines and maybe things that are a little bit more complicated like ellipses and so forth. And we were trained to, everyone has been trained to look at the world that way and to see the patterns that are in the world basically is composed of these very simple standard geometrical forms. Well, this man, Mandelbrot, and some other people who have helped his work considerably, started seeing that there was an entirely new universe of shapes that had never really been studied before and had certainly never been seen in nature. And he called these things fractals. And that's a sort of intimidating term that doesn't have to be as intimidating as it really is. The fractal shape is one that usually has a kind of self-similarity. Dr. Landscheid showed some pictures of those the other day, which simply means that the structures or the shapes will repeat themselves at finer and finer scales. Sometimes not identically, but there's always a similarity that connects the repetition of the shapes at lower and lower scales. And in fact, this Mandelbrot, mathematician, began to look around in the world and in nature and in economic cycles. He's had his hand in those as well. And he began to see, or at least thought he saw, these shapes everywhere. And if you read a popular book of his called The Fractal Geometry of Nature, you will find him full of the same kind of sort of evangelical spirit that you find in the other, in the people who are advocating chaos theory. In other words, he says, let's retrain the intuition, let's look at nature in an entirely new way. And the clouds don't have the shapes that you think they do. Everything is really these very complicated, self-similar, very complicated from one point of view, but very simple from another point of view. I mean, they can be easily defined. It's just they can't be easily resolved into the standard geometrical shapes that we, are accustomed to thinking in. So there is this, both from the mathematical side of the fractal geometry and also from what you might call the more dynamical side of chaos theory, there has been this fascination with a new way of looking at nature. And what I want to talk about a little bit is what vistas, what new shapes, what new patterns, what new things, what new beings are really being revealed by this, because it's not entirely clear that the people who are doing this work realize that, and it's not they're not trying. It's certainly it's not that they're unintelligent. It's just that this is something very difficult and very hard for people to penetrate into, because people haven't looked this way before, or at least they haven't looked this way for many years. So what I'll try to do is sort of take some of the simple concepts that you've heard and maybe try to talk about them a little bit, sort of maybe take them down into levels that are a little bit more obscure and so forth, but and maybe give a few hints about what I think is really being seen by these people and perhaps not recognized for what it is. And somewhere along the line I'll try to say that has something to do with astrology. But anyway, when I was talking to Rex Shuda yesterday, he said, did I know where I was going to start? I didn't entirely know where I was going to start. I said I was going to sort of look for the look for the end of the thread, and he put this cartoon image in my mind of where you grab the thread and the guy goes like this, and then there's nothing left. He pulls it all out. So that may happen, or it may not happen. I may be pulling the thread right out and be left with a loose end. Anyway, now I will encourage questions, but I'd rather not have questions of a sort of technical mathematical kind. We can always go into those later. As a matter of fact, you might define a question as one of a technical mathematical kind as anything that would cause me to use the blackboard. Okay, Last year when I had to do a drawing on the blackboard, Michael gave me this little marker, and I was trying to draw something, and I would hold the cap off the marker, and I would talk for a while, and then I would go back there, and it would be all dried up, and nothing would happen. And in order to prevent that from happening, I will talk, but please ask questions as we go along. Okay, now the first concept that you have all heard of, and we've just mentioned already, is the concept of self-similarity. Now, first of all, it's important to say that this concept of self-similarity has only been introduced and researched in the context of geometry. In other words, static shapes, you might say. It is very, very tempting to say that because the large structure is reflecting structures at a lower level, it's very tempting to say that this is a metaphor or an example of as above, so below. Okay? And it's very tempting to just go scurrying in that direction and simply say this is a way in which these new concepts can be used in astrology. Now, without trying to take anything away from the metaphorical significance of that, I want to just state clearly how it is being used, and then we can come back to maybe the broader significance of it. The man, Mandelbrot, who was first talking about these, or investigating these shapes, was finding them in nature in sort of a snapshot form. Okay, in other words, if you look at a cloud, you look at smoke curling up off a cigarette, you do anything like that, they will have these structures as a sort of in a photographic fashion. You can also understand these shapes to be present in time series if you understand the time series to be represented by a straight line and each event as occurring along that straight line. In other words, one of the first examples that Mandelbrot himself discovered was errors in the transmission of signals on phone lines. They would seem to be clustered into little pulses, and within each of those pulses there were little moments of silence, and then within those moments there were little pulses. So the spreading out of these events through time, in fact, could be said to have a fractal structure also. The difficulty is you can't move from that and say that the events that take place at, say, the macro scale or the scale of the solar system are being reflected at a self-similar scale by the events that are taking place on the Earth. You can't immediately make that jump. I'm not denying that there is that connection. I'm just saying that the fractal concept itself, as it stands, does not allow you to move from a spatial scale, something that is defined at one spatial scale, to an event or a sequence of events that are happening temporally at a different scale. That would be perhaps a mistake to apply it in that way. I will want, in a few minutes, I would like to say maybe another way in which we could try to apply it, something that might be even more suggestive for astrologers. The other concept that you will hear frequently, another concept, not the only other one, is the butterfly effect. Not really a concept, but a phenomenon, which has to do with a property of systems, nonlinear systems. I'll try to say something about nonlinear in a minute, which is that these systems are very, very sensitive to very small shocks. If you have a water that is boiling, and well, let's not take something like that. Yeah, we could do that. If you have water that is boiling, okay, and you're putting in a certain amount of heat, fixed amount of heat all the time, even though it's very, very turbulent appearing, there is a kind of uniformity and a kind of regularity that this turbulence has. But you throw an ice cube somewhere in there. If you affect the system in any way, even in a small way, that can have repercussions on the state of the system somewhere else, and it almost certainly will. The problem is that in the systems that people are studying in chaos theory, systems that have attractors, and we'll come to what an attractor is, that those very small shocks causing the system to change will, in fact, their effects will be very, very peculiar. It's not that they won't have an effect, it's just that the system will revert back to the attractor. It will go back on the path that it was really on all along. the effect will be very transitory. The problem is that it will jump on the attractor. It will be somewhere other than it would have been if it had not been affected from the outside. So it's tempting for people to say that, again, just to use in a direct way, to say, well, the butterfly effect, or this property of systems, that they are very sensitive to changes in their conditions, is something that could just be could justify the action of a distant planet on a system on the Earth. Well, maybe the gravitational influence of that body is very, very slight, but that doesn't matter because it's still having an effect on us. Well, that is true in a limited way, but it's also true that it does not really affect the life path of that system. It doesn't really affect the path that it's on. It may maybe put it a step forward or a step backwards, but it doesn't really change the actual direction that that system is really evolving or developing in. So related to that, let me just say something about attractors, because these attractors, and this is one of the reasons why the physicists themselves are getting so fascinated by them, they're very odd objects, at least chaotic attractors. These attractors have extremely strange properties. If a point begins in a way that's not on the attractor, as the system evolves, that point will be attracted by the attractor and eventually end up on it. However, once it's on the attractor, then you might say that the point that begins somewhere outside of the attractor is slowly being attracted to some point on the attractor. But once it gets to that point, the point says, I don't want to see you anymore. And then it's forced to move to separate on the attractor itself. In other words, it's sort of this very, very strange dichotomy. The attractor tends to attract all initial states to it, but once a given initial state is attracted to it, then all the states on the attractor tend to separate. So you have this very, very peculiar idea that you know, on the one hand, things are meant to be pulled to the attractor, but then all the states that do lie on the attractor have a tendency to go further and further apart from one another. So it's a very, very strange notion. It isn't like anything that was there and present in physics before. Now, all of these attractors are not really, at least as it's been studied so far, these attractors themselves do not exist in, at least as we understand them yet, they don't exist in actual space. I mean, you don't point to, I'm not saying that centers of mass could not be used as attractors. I'm saying that as they have been studied so far, these attractors have a very abstract existence, and that has to be understood. They do not exist in physical spaces that you look around and see in your everyday life. They exist in very abstract spaces that are called phase spaces. Now, a phase space is partly abstract because the variables that correspond to the coordinates are not themselves, it's not like a map, it's not like a street map where the vertical coordinate represents the north-south direction and the horizontal coordinate the east-west direction. They stand for very strange things. For example, the horizontal correspondent might refer to a distance, but the vertical coordinate will refer to the velocity. So you have a very peculiar sort of, and there will be shapes in this coordinate system, but the shapes themselves do not have, they are not shapes, actual shapes of something in nature, but they represent or symbolize events that may be evolving in a certain way in nature. So they have a very peculiar existence, and most of the work that's done in chaos theory, when these men are watching their computer screens and seeing these strange shapes evolving and so forth, they're all watching the evolution of systems in phase space. Any questions so far? All I'm trying to do to this point is just simply get fairly clearly in mind what chaos theory has been claiming so far and what bearing that might have on some larger issues, so that we can just sort of clear the ground a little bit and then begin to maybe speculate a little bit more. Let's maybe talk about one more concept that's very important and has to do with information. And there isn't a lot of coherence to chaos theory yet, in my opinion. There are very, very interesting methods and descriptive methods, and there are, sort of brilliant predictions that have been made, but the understructure, the basement level, is really a little bit messy and a little bit fuzzy. One account of how systems evolve dynamically, okay, is done in terms of information theory. Okay, and it's a very interesting account, and it has some very, very wild consequences, and that's why I'm mentioning it right now. If you are boiling water, you are introducing energy from the outside. And according to this account, what happens is this energy, which you could even have energy that was pulsing in a certain regular pattern, that this energy, as it comes into the system and starts scaling down to the molecular level, where we think the heat is basically stored, or what is heat, the motion of the molecules. As the energy scales down, it randomizes. So if you have a pulsing source of energy, pulsing heat, anything of that sort that is being introduced, this signal, the information that is contained in this initial signal, is becoming randomized. And in a sense, you would think that the information is being lost, because it gets jumbled down into the molecular level that is being understood primarily as the random motion of particles. However, we do notice order in these systems. So the people who are trying to understand this in terms of information, the loss or gain of information, then understand that after the energy has gone down to the molecular level and turned into basically random motion, then it starts to scale up again back to the large scale. And as it does so, it follows a certain pattern, which is that attractor that we just mentioned. In other words, you might say that in complete contradiction to Heraclitus, that the road up and the road down were not one and the same in this case. Now, in other words, we go down and we randomize and we come up again in accordance with an attractor. The very strange thing about this is that the pattern that is created as the energy scales up again, and the way in which that pattern is measured and exhibited, is not always in a very normal and obvious relationship to the pattern, the pulsing energy that was introduced at the beginning. There can be very odd distortions in it. Sometimes it's very hard to set up a one-to-one correspondence. If you have a pulsating or oscillating source of input energy, there may be a cycle that arises out of that, but it might not even be a cycle that has the same period. It might not even be a harmonic of that cycle. It may not even be a tamed or a stable cycle at all. It may be something chaotic. So the question is, what's really happened here is you have energy that's gone in, that energy that maybe contains a message. It has a certain period or a certain structure to it, but when it comes upscale, it seems to be changed. According to one account, and this is not necessarily one I endorse, but one interpretation of all these events, that's the creation of information. In other words, the energy is new information is being created by these dynamical systems. And the people who have this particular view of chaos theory become very, very adventuresome with it, and they say, well, that's how life arises, and that's how evolution change. They generalize very far beyond that. But it's an extremely interesting view that in some way it wouldn't be just that there was energy or information that was present in different forms, and that information was always being preserved or just being moved around, but that new information was being created by these dynamical systems. If we just occurred to me, we might try to do a funny, just an interesting extrapolation of that. Okay, well, let's just imagine that the energy, you're boiling water, you're putting energy from the outside. That signal, whatever information is contained in the initial signal, scales down, randomizes, and starts to come back up. That means that to some extent it's almost as if the attractor, or the path up now, is somehow being guided by something more global. Okay, it's almost as if there's a holistic element to this. that as if in the path up that there is a structure that is guiding the organization of the system from the outside, not from the inside. We tend to always think of the behavior of systems atomistically, that everything can be resolved ultimately into the motion of these particles. But what this would indicate is that there is a sort of guiding principle that is always outside of the level that you're thinking about, always one scale up, okay? And that guiding principle is what is controlling the organization of the system as that energy scales up. Now, what just occurred to me is that you might try to go beyond that point. Most of the physicists, most of the systems you study, boiling water, you are an observer, and you're looking at it from the outside. So you are at the global level already, and you're trying to figure out what's happening at the micro scale, where you can't see anything. But now let's imagine that the energy is scaled up. Now here we are back at the level where we human beings are observers, but you could continue that process, and you could think of us not so much now as observers of a system that we are seeing at the global level, but we could be participants, you might say, in a larger system. People are moving around, bodies are moving around, everything here. We're now effectively at the analog of the microscale. And we see things, when we look at things around us, we're at this microscale. Things don't seem to be that disorganized. People seem to do things for reasons. This doesn't seem to be random motion, or unless you're a real skeptic. Unless you're a real skeptic about human life and everything, things seem to be fairly orderly at our level. But what happens then, if we're sort of now at, so to speak, at the level where the molecules were before, it seems like perhaps this tendency to sort of sweep up and for the higher levels of organization to be dictated from something outside the system could just be continued. We could go up into the level of the Earth as an entire system, and we could go beyond that to the solar system and anything of that kind, where it would appear as if the organizing principles for what really happened here were in fact something outside of the system, something at a higher order. That would be perhaps one way of thinking about and maybe giving a little bit more precision to the concept of holistic, instead of just thinking about it, whole instead of part. That somehow the ultimate definition or controlling or organizing features of a given system were always at a larger scale. Now here we come back again to the as above, so below, but from a sort of a different standpoint. I mean, it's almost as if there is in fact an organizing principle that is at a higher scale, okay, and does have some relationship to what's taking place lower, but it's not necessarily in a neat one-to-one correspondence anymore. It's not as if there's a certain pattern here and it's being repeated identically at the higher scale. Because of these strange transformations that take place in chaos theory, it may very well be the case that the higher level order that is really controlling the organization at a lower order does not reflect it in a simple or direct way. It may be more symbolic, or it may be more involved in that. Any questions? Yes.
Chaos theory, any connection with fuzzy logic?
Not yet. Not as people are thinking about it, unless there's some new development that I'm not aware of. I mean, you might try to make a connection in that direction. Chaos theory, as it stands right now, is meant to be something that is exact rather than something that's fuzzy. In other words, even though the systems appear to be very, very hard to understand, hard to describe, they are the result of extremely specific, highly defined conditions, or input parameters, or whatever you want to call them. So I think fuzzy logic is coming from a very different direction. I think we could talk about fuzzy logic in different contexts, but
Yeah, actually, correlating what you were talking
Mhm.
to a very old Indian system where you're talking about the phase spaces, and immediately I was thinking about what they call Tahiti, which was
Mhm.
around the universe.
Mhm.
And they had the Roger Thomas, somebody help me out. Thank you. Consciousness, energy, and matter, which
Mhm.
are attractive.
I didn't hear the last part of that.
Which are,
They had what?
well, it
Uh-huh.
translates to consciousness,
Uh-huh.
energy, and matter,
Yeah.
which are attractive. And they
Mhm.
were on that playground.
Mhm.
And how they dance around and how they, whatever they do to create
Yes.
attractions
Well, it might be. There's an article that might be just as hard to follow as I mean, more as mysterious that I wrote about something that's like that. It's in the Matrix Journal. Yeah. Yes, I understand. I understand that. I mean, I'm not trying to discourage any thinking in that direction at all. But I'm just saying that we do it with a little bit of, care for now. And I would be interested to talk about that later. Yeah. And hear more about it. Yes, please, go ahead.
One question. If you, for instance, say you have a pulse, like your boiling water example,
Yes.
you have a certain pulse.
Yes.
I mean, if you vary the pulse, could there be a variation in the result?
There will be a variation in the result, yes. But again...
It won't reflect necessarily the pulse, but there should be a
Yes.
variation for every variation.
Yes, there is.
Chaos if you put too much energy into the system.
That's right.
Steps, second, two periods, 4
Yes.
periods, 8 periods,
Yes.
and then suddenly chaos.
So there'll be a ratio.
There will be an order to the way in which the system changes its behavior as you vary things like the input parameters. And that's been studied a great deal. And some of it's extremely interesting and just baffles the imagination. A very interesting feature of that, we could maybe talk about that in this context. You have the system, the boiling water, or you have another really good example that's used a lot is a pendulum, an ordinary pendulum that is being pumped. Now, ordinarily, the pendulum just moves because of gravitational things until it stops. But, yeah. Yeah, or coupled pendulums. But you can have a sort of extraneous driving cycle for that pendulum. It's almost like you keep pushing it whenever, and you can do that in certain frequencies. And then the behavior of the pendulum will not be as regular as you expect it, and sometimes it can actually be chaotic. So it's a very simple system that can be used, just a second, to study that. Now, the thing that's interesting about these systems, as you vary their parameters, like you suggested, there seem to be certain universal properties that pertain not just to that one system. In other words, the variation, the rate at which the way in which the behavior of the system changes, can apply to another system that's defined by entirely different equations. And this is what really surprised people when they first learned about these things. You could have a system that was defined by ordinary x's and y's in a simple way, algebraic polynomials or whatever it was, in a simple way. And you could have a system over here that was defined with trigonometric functions, sine curves and all kinds of things like that. And they didn't seem to have anything to do with one another. As a matter of fact, according to sort of traditional thinking, it would mean, because of the sort of different classes of the defining equations mathematically, it would mean that the systems really had to have different natures in some way. Now, one of the most interesting results of chaos theory is that many of the properties that they discover as they vary the parameters seem to be universal to systems that don't appear to have anything in common. And not only that, they are so broadly different that they don't even seem to be related to one another as sort of genus to species anymore. I mean, you might say, well, this is just a more general. It's not that the one system is just a more generally defined than the other system. It's not that one is just has a more universal set of equations, and this one is just a special case of it. Instead, they seem to be entirely different systems that have entirely different defining equations, yet they have the same properties as you study them, as you interfere with the system and see what happens. That might, if you had a sort of a more classical orientation, you might use as you might think of an old idea that goes way back to Aristotle, whereas the categories are things that are not unified by the relation of genus to species, but they're unities of analogy. They are a unity of analogy. And we don't even think this way anymore. I mean, Aristotle says that, for example, that a magnitude and a number, they're both quantities, but they're not quantities in the same way. And so they don't. So even though the property of being so big applies to both of them, it doesn't apply in the same way, and it's not a relationship of genus to species anymore. One of the most surprising examples of something like that for us is an example that Aristotle has where he says that he defines life as something that, not a system, but as something that will take nourishment and grow and reproduce itself. And we'd say that's a great definition of life. And Aristotle says that's a bad definition of life because it applies equally well to plants and animals. And plants and animals exist in a different way. Yeah, it's a weird, we don't think like this anymore. See, we just think of hierarchical unities, right? Where every step, every structure above another structure that's related to it could be understood as a different level of generality. But what is interesting about chaos theory here is it's not just generality we're talking about. We're talking about sort of unities that are unities by analogy as well. Now, the only thing I can think about when I see this is I keep thinking archetypes, okay? Because an archetype is not just a general concept. It's not a concept like, you know, a concept that has very special, special versions of it at smaller scales or greater degrees of specificity. I mean, what are your archetypes? I mean, you study archetypes. They're very broad things. If you look at a planet and you see all the keywords that pertain to that planet, they're very strange, right? They have something, they seem to belong to that particular archetype. They have some whimsical connection, perhaps, but they are not just all related to one general or universal concept. In some way, it's a unity of analogy or a unity at a broader level. Now, my claim is that chaos theory is in fact beginning to interrelate systems at a level that's almost that broad. In other words, it cuts across the boundaries of standard physics, the boundaries that were laid very, very carefully in terms of the defining equations. Instead, they find that a system over here and a system over here have the same general property, and in fact, you can even use one of those special systems to model another, and all kinds of things like this. It appears that these interrelationships are much more subtle than people thought before. Well, that's an interesting example of an archetype as far as I can see. And you might go as far as to say that perhaps if you could get general enough in studying your dynamical systems, you might be able to pinpoint the individual elements that distinguish different archetypes from one another. For example, any dynamical system has to have, you might say, a ground state. If left to its own devices, it will either be stable, perhaps it will fluctuate in a periodic way, or perhaps it will fluctuate in an irregular way. But that system also has an internal principle that will damp it. It may be an internal or external principle that will sort of curb its behavior. It might be friction. It might be other kinds of damping. It might be heat dissipation. Okay, there's a whole different variety of possibilities. Furthermore, that system could be affected from the outside by different types of input energies, periodic driving cycles and so forth. What I'm saying is you can take these real broad categories and say, well, this particular system has an internal resistance. But on the other hand, it's being affected by this kind of external principle, but it has this ordinary state. And if you study it at that level, it appears that the properties are almost universal. In other words, anything that could be defined in that way would have those kinds of properties. I mean, you might stepping on my cord here, right? You might think that anything, I mean, when you think of your own life, I want to do this, but I'm feeling an internal reluctance. I'm being curbed internally, to do this. And something is, the resistance is from the inside, instead of saying, well, every time I try to do this, I encounter an obstacle, on the outside. Okay, and you could try to generalize these principles and really start building a bridge between these archetypes of nature, which is what we're talking about with these dynamical systems, and things that were perhaps archetypes that would be more compatible with the way traditional astrology has been talking about them. Any other questions on this particular harangue? Yes.
One about the lecture and one about the structure.
Yes.
As above, so below. May I say that
Yes.
the structure is repeating?
May you say that the structure is repeating?
Yeah.
Which in which example, in which concrete situation?
What you were saying.
Yeah, I would say that the structure repeats itself at different scales.
Okay.
Yes, I would use the term, yeah.
So, I may also say it's a structural identity of structure.
A structural identity of structures. Yes, what we're doing is we're talking about a hierarchy of things here. First of all, these have the same structure, and the way in which the structures are related at different scales itself has a structure. You could say that, yeah. You could say that, definitely. As a matter of fact, this is similar to the idea of entangled recursion, for example, hierarchies. You could say a neat and simple way of trying to study dynamical systems is to divide up reality very artificially into a kind of machine, a kind of recursion machine that takes a value, runs it through a certain rule, okay, and gives an output value, and then comes back to the beginning and runs through it all again, and keeps putting the output value as the new input value. But the more complicated recursion rules go back and modify the recursion rule itself with each new output value, and that's more entangled, and that's partly what I'm trying to suggest with the as above, so below. If we understand the information as being sort of somehow organized from the outside, by the time we get to the outside level and we understand the different scales and the different stages that have taken place, it may not be a matter of one-to-one correspondence, but there's a link there, nevertheless. Okay. Although I must say, just from listening to Dr. Landscheidt's lecture, that the links do seem to be so one-to-one. I mean, driving, a period. The periodicity at the solar level seems to be repeated with the same intervals, and frankly, that baffles me. It's almost too good. I don't know what to say about it. Just there must be something wrong with my thinking.
No, you are quite right. I, in the beginning, didn't believe in it.
It's too good. Yes.
Because it was too good, and so it took a lot of time to realize
Yes.
that it was real.
Yes.
And then I always try to make predictions. And when I get fine results and predictions,
Yes.
then I really think it's there.
It must be thereafter. You don't believe yourself at first, right? Yeah. Well, I'm at this point. I had a talk with Rex yesterday. I couldn't quite, from my understanding of chaos theory, at whatever level that may be, I think of all these interrelating systems, and I can't follow how it will turn out that they're all, period to period, peak to peak correlations. So anyway, there's something very magical about that. Yeah, yeah.
And yes, it's not only chaos theory. It's not only theory.
Yes.
You can look at special states you find in nature.
Yes.
Magnetism, non-magnetism,
Yes.
for instance. Then you can go to a boundary
Yes.
that exists, Curie temperature.
Yes.
Because when you go, when there's a phase transition to this boundary, you get from one state to the opposite.
Yes.
From magnetism to non-magnetism, or from non-magnetism
Yes.
to magnetism.
Even though, yes.
And when you apply this technique, this formalism, then you get wonderful pictures again, different,
Yes.
and you can learn from them,
Yes.
and they are related
Yes.
to what you learn as a physicist. And when you take different materials, different coefficients, you get different pictures,
Yes.
which tell you again things you didn't know before.
Yes.
I've got some pictures with me, done by Peiting and Richter,
Yes.
and related to magnetism, non-magnetism, and so we see it's a pre-image,
Yes.
but this pre-image seems to be related to reality
Yes.
in a rather exact, precise
Yes.
way, so that we can even get quantities and see how different materials react
Yes.
physically.
Yes. I want to pick up on the pre-image right now. Okay, can I do that? No, I want to say something about it, and this may not be really clear, and stop me if it isn't. I'm really interested in this idea of a pre-image. If I understand your use of it correctly, I think we would a lot of times tend to think of it as a kind of model. Is that correct? Okay. In other words, you would call it a pre-image because it's not an image in the ordinary sense that it looks like something. It's not a pattern you will actually see, but it's more like a schema. Would you use the word forebuilt for it? Okay, something like that. It's sort of like it's a more schematic representation of patterns that could be discovered. Okay. Now, to me, that is analogous or similar to the idea of a model, okay? And we all know mathematical modeling in some way.
But it's a bit deeper.
Bit deeper,
because
yes.
We're always dealing in physics with models.
That's right. That's
that
right.
are created artificially.
Yes, I understand.
And sometimes are in no relation to nature.
That's
at
right.
all.
I understand that.
So
The problem with the
this
model is you can make the model before you do anything.
The
Yes.
model has been deteriorated
Yes.
by the use of models
Yes.
that were not ideal at all.
Well, yes. 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 About this topic. Well, I want to go into this for just a second. Just I want to maybe this will answer your question. Just hold on 1 minute. I said at the beginning that I thought that the people who are doing chaos theory, both the people who are looking at the geometrical structure of nature, fractal structure of nature, as well as the people who are studying it dynamically. By the way, these two approaches have not yet come together. This is something that's really almost, it should make you think that perhaps they have not seen clearly what they're trying to see. Because if you take the boiling water, you can take one point in that boiling water, one spot, okay, and you can measure the temperature as it evolves through time, and you can in fact find, and you put this in one of these phase spaces we talked about, and in fact it will return and have a very neat structure at that one point, okay, as it evolves through time. On the other hand, you can look at the boiling water in a photographic fashion, statically, as if you took and you can say that it has a certain fractal structure. That way, a conjecture by Mandelbrot is that in turbulence, boiling water, the isothermal surfaces, the surfaces where all the heat is exactly the same, okay, the temperature is the same all the way around, that have a fractal structure. Okay, that means that if you look at a photograph of boiling water, and you could somehow see where all the heat, all the places where the temperature was the same, if you could sort of trace those all out, all these surfaces would be inner sort of folded in a way that had a fractal structure. So you can say something about it statically. You can overall, okay, you can say something about one point in it as it evolves through time, but you can't bring these two views together. In other words, you can't really get a complete picture of what turbulence is. In other words, you can't see how the whole picture evolves through time. There is a bifurcation in the view, and that's a real stupid mathematical pun, right? Anyway. You can actually, and this is a problem. Now, what does something like that mean? Does it mean that the mathematical methods that are being applied are just not good enough yet, and if we just keep going along the same path, we'll bring these two together or something? Is that what it means? Well, that could be what it means. It doesn't mean that we have to get more and more complicated equations or study things in higher dimensional spaces, model them in all kinds of complicated ways, just in order to bring the static and the dynamical together. Well, that's one possibility. Yes?
To make a suggestion, we should look at nature, how nature does it.
Learn from nature,
and then
yes.
learn from nature, looking at this sun.
Yes, yes. That could suggest the unities that are there. It could show us, and that's kind of what I would like to say, from a different point of view. But I think it amounts to something largely similar. If you take, am I running out of time?
No, I started late as well, so I'll let you know. But I'll do the
Okay. Yeah.
I had a question over here that was never.
Okay. I'll get to that in just 1 second. I'm sorry if I missed. Was it your question that I missed? Okay. Yes. 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 Right. As you pump it, yeah, right. Yeah, that's a good example. That's right. Yeah. Or as you try to, if somebody tries to push you, you have problems. Sometimes, that's a good nonlinear dynamical model. Let me just sort of quickly pick up on this a minute, because Dr. Landscheid suggests that what we ought to do in order to somehow find what it is that unifies this static view, fractal view, and this dynamical view, is that we ought to look at nature itself, supposedly as, nature, what happens in nature, presumably being one thing, and that we've somehow artificially resolved it into two things in an incorrect way. Well, I'm trying to say something a little bit similar to that. I think it is. But what I want to go back to just for a minute is touch on the idea of a phase space. Okay, this phase spaces where we, just to repeat again, where we we don't have an actual map. It's not an actual picture of something that you could go out and find, but the vertical coordinates and the horizontal coordinates are themselves represent things that are in a more abstract, represent a system in a more abstract way. The vertical coordinate might be the velocity, and the horizontal coordinate the distance traversed. In the example of the pendulum, for example, the pendulum has a certain angular displacement through time. That could be represented on the horizontal axis, whereas the instantaneous velocity could be represented on the vertical axis. Now, and that could be a picture, you might say, an abstract picture, a model of what is actually taking place with the pendulum. It doesn't show you the pendulum moving. It's not a picture of the pendulum. It's an abstract version of the pendulum that can only be set up if you use these conventions. You know, this is the horizontal axis, this is the vertical axis. Now, what I'm going to do is I'm just going to say something very quickly about phase spaces. Although they arose in the last part of the last century, primarily in the study, or they came into their own in the study in thermodynamics, Gibbs, some things like that, and they were picked up in quantum theory, and they've been used just enormously in studying quantum theory. There's a very curious anticipation of this that goes way back into the late 1400s, where a bunch of people were trying to understand the problem of motion. Now, these men were coming out of a very different tradition, Aristotelian tradition primarily, and they thought of reality as broken up differently. They thought that you could look at you could look at nature as we do and see certain extended bodies, things that had lengths, you know, depth, things like that. No, we could see quantities that, you know, heaps of things that could be counted in different ways. But they also were interested in the qualitative part of nature. Colors, light in particular, they were fascinated by light. And the fact that light and colors can have different intensities. In other words, something can be a more intense red and still be red. So there was something very, very, very startling to them about this, something that we can't easily recapture in an original way anymore, because we think of light as, you know, as a wave form in some way, and we think of the amplitude or the intensity of the light as in some way the vertical displacement. What? Supposed to move back? Oh, okay. Sorry. I'm creeping forward, right? Now, the people who tried to study motion and the whole realm of qualities, colors, they thought of motion as having a qualitative aspect as well as a quantitative aspect. Weights, the moment of gravity, we think of now, things like that. These people tried to graph a motion of a body, but they didn't put the distance on one axis and the time on another axis as we're accustomed to doing. They put what they called the intention, this is I-N-T-E-N-S-I-O-N, of the motion, the intensity of the motion, what we now would tend to think of as the instantaneous velocity. They put that on the vertical axis, and they put the distance traversed on the horizontal axis. Now, when they did this, and you can draw a line that represents the way in which the motion may be changing. Uniform accelerated motion looks like a straight line when it's represented in this fashion. Now, the odd thing about this is when we do a distance graph versus time, and we draw a curve in that space, that curve that we have drawn is a picture. Again, it's not a map. It's not a perfect image of a motion. The perfect image of a motion would be like a street map, or not of a motion, but of a place would be a street map. This is more abstract. Distance versus time is not as immediate. You know, the motion looks like this. It's a representation of what is actually taking place. But when they used the instantaneous velocity or the intention on the vertical axis and the distance traversed on the horizontal axis, they thought of that not as a picture or representation of the relationship between distance and time, not even as a picture or relationship, picture of the relationship between the velocity and the distance. Even though that's what they had used on the coordinates, they somehow thought of this as a picture of the motion as a unity. That's one thing. This was a picture of the motion. It was a figurative representation of the motion that's very different than the way in which we think of things. We think of anything in a space as being every point in a space as being ultimately referred to coordinates, and we think of any trajectory or any curve in a space as being a relationship of these coordinates. They were not thinking of a relationship of different coordinates. They were thinking that every entity, anything that was real, had a quantitative side and a qualitative side, and somehow there was a fundamental unity of those two. Motion was one thing, even though it could be resolved into an intensive element and an extended element. Now, the not going to be able to do this entirely, but what I will do is try to say that the idea of intensity or intention as something that was instantaneous. We use instantaneous in terms of sort of a limit of extension. It's like the smallest limit. You think of an infinitesimal, a differential as the smallest unit or the smallest element that you are now going to talk about in terms of extension. Well, they thought of that element that was sort of the limit of the extension thinking. They thought of that element, that one little tiny thing that was supposed to be indivisible, they thought of that as the intention. And that was all something that happened within a moment. It was all instantaneous. They thought the intention was something that was momentary and unified in one, and the extension was something that took place through time. Now, I think that behind chaos theory and behind the people who are trying to use these pictures, these new graphing techniques and whatnot to penetrate deeper into nature, that ultimately what they are seeing, what they're trying to see is they are trying to see a fundamental unity between the intention that bodies have and their extension. And they can't quite get that clear, and they can't quite resolve it for one special reason. The reason is that we have a concept of modeling. And that concept of modeling makes us look at everything that is intentional as in an indirect way. It makes us represent them in terms of extended magnitudes if we want to understand the intensity of